Hello everyone. Hey, okay. This video I'm going to demonstrate the derivative rule for power function. Okay, and use a very simple proof to show you the rule for derivative on a power function. And let's start. Okay, I hope you learn this in calculus class. So what is a derivative? A derivative is a calculate the tangent, the slope near a point. Suppose we have function. Okay, this is a function. This curve, this black curve, is a function, and it's arbitrary function. No matter what, we don't need to care what the function it is. If we want to try calculate the slope of the function at near the x, so what should we do? As we would take a point near the x, we call it x plus delta x, and then we just use the definition of the slope, right? F of x plus delta x minus f of x divided by delta x. Okay, this just the slope. Where is my pen? It's just slope near x. Okay. Okay, slope near x. Okay. Okay, so if the delta x is very, very small, very approaching to very close to zero, okay, and this formula is just, you will become the slope at x, okay, so that's the original idea of the derivative of function. Just calculate the slope near one point, near a point. Okay, and for the power function, you in the calculus book you will say, okay, derivative of xn with respect to x, you will tell you a formula like this. It's become n times x n to the power minus 1. Okay, and then I will use the original definition to show you this formula. Okay, so that's now, okay, our f of x is x to the power n. Okay, so let's put this okay, let's put this formula. Okay, and I need to write this. Okay, if x approach to 0, this should be, okay, this should be, okay. Okay, maybe I will move this a little bit. Can I move this? Sorry. Can I move this? Okay. Sorry. Yeah, sorry. Wait for me. I try to move this part. Okay. Sorry. Okay, I should write a df over dx here. df over dx equal, okay. Okay, so let's write that. Okay, dxn over dx. Okay, so let's put in the definition. F of x delta x. Right now, our function is x to the power n. It will become x plus delta x to the power n and minus xn, and denominator, yeah, right, there is delta x. Okay, so we have a problem here. So what is this? X plus delta x n to the power n. So I think, did you learn the binomial expansion in your high school? So let me write down x plus delta x to the power n. It will become x to the power n plus combinatorial SCN1, and it's x n minus 1 times delta x 1 plus cn2, x to the power 2 dot delta x2 and plus cn3 x2 sorry, this is wrong. Let me yeah, did it right. N minus 2 is n minus 3 dot delta x okay, delta x to the power 3 and keep continuing. Okay, this is called binomial expansion. If you can check this, yeah, you Google it, binomial, yeah, binomial expansion. Okay, so we just put a binomial expansion to the definition of slope. So what will we get? Okay, let me move this upward. Okay, so what we get? We will get this one. Okay, let me write down this. It is a very long fraction. So xm plus cn1 x minus delta x plus cn2. I think 2 term is okay. Yeah, we don't need that much term. Delta x to the power 2 dot 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 dot. Maybe I just write one more. X to the power n minus 3 delta delta x3 dot 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 dot. Okay. And finally, we want to minus x to the power n. So don't forget this. This is f of x. This first term. We need to minus x to the power n. Okay. So we minus f to the power n. What do we left? Okay. What do we left? Okay. We are going to get answer. This is delta x, and we will find cn1 x to the power n minus 1 delta x plus cn2. Yeah, n minus 2 delta x2 plus cn3 and x n minus 3 delta x3 dot 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 dot. Okay, and then we really divide it by delta x. What will we get? Okay, next step, we divide it by delta x. So what will be left? We have cn1 x n minus 1 to the power 1 plus cn2 x n minus 2 delta x plus cn3 x minus 3 delta x to the power 2 dot 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 dot. Okay, so we already get it. We all get the answer. So let's back to the definition of derivative. The definition of derivative is delta x really close to 0. So okay, so I need to make a description here. So limit delta x approach to 0. So okay, so after we get this equation, limit delta x to limit delta x approach to 0. Okay, since delta x is very approach to 0, so delta x is total 0, so is delta x squared. It's also approach to 0. Yeah, if a number is very close to 0, it's square almost much more closer to 0. So this can be cancelled out. So what we get? So our final result will be where is my pen? Here. It will be cn1 x to the power n minus 1. And cn1, the factorial cn1 is equal to n, so it's xn minus 1. So that's this that's why this rule comes from. Your derivative x to the power n make derivative with respect to x, it becomes n times x to the power n minus 1. Okay, but when you do a derivative, you don't need to show the whole process again. This is just to demonstrate, to let you convince this rule, what this where this rule comes from. In real situation, when you're trying to do the calculation, just just put this, just write down this formula. Okay, you don't need to do the derivation all over again. Okay, that just makes you convinced to these derivative rules. Okay, so don't forget about this derivative rules. Yeah, this is very easy derivative rule. Okay. Okay, so I'll stop video here and see you in a other video. Bye bye.